Hello guys, welcome to this lesson on vertex form of a quadratic function, the first lesson in the chapter. So this is where we officially talk about quadratics. Alright, let's get started. So the essential question, how does the equation of a quadratic function in vertex form highlight the key features of the function's graph? So our learning goal today is to be able to identify the key features of quadratic functions. So in order to do this, you need to understand what a parabola is, what a quadratic function is, as well as the vertex form of a quadratic function. We'll be putting a lot of emphasis on the vertex form today. All right, so how do we represent quadratic functions? So a function is called quadratic if its equation can be written in the following form, where we have ax squared plus bx plus c. So this is the form that we want to use. So in this case, a cannot be 0. So basically, if you have a power that is 2, that means that if the highest power is 2 in the polynomial, then you have a quadratic function. So here are a couple of examples. So if you had f of x equals 2x squared plus 5x minus 1, that's an example of a quadratic function. So here in this case, you have your a, b, and c. So this is a, b, and c. So that's an example of something that is quadratic. So all quadratic functions, regardless of how they look like, right, are transformations of the parent function f of x equals x squared. So x squared is basically the parent function for all of these guys. All of these guys are just transformation versions. When you graph these guys, you're going to get what we call a parabola. So that is a shape that looks like this. So it's either like a U shape or an upside down U shape, depending on whether it is a positively it's positive x squared or negative x squared. So we're actually going to talk about this in this vertex form. So the vertex form of a quadratic function is given by f of x equals a times x minus h squared plus k, where hk is the vertex. So the vertex form is useful because it highlights the vertex of the graph. So this is why it's called vertex form, because it allows you to identify the vertex directly from the equation. So we're going to give you an example of something that is in vertex form. So let's say we had f of x equal to negative 2 times x minus 5 squared plus 3. All right, so in this case we have our a term, we have our h term, and we have our k term. All right, so let's briefly talk about the a term. So what does that do in the graph? So we're going to actually talk about these transformations in a little bit. So we're going to talk about what each of these do. So this is a, this is h, and this is k. So you can see that the vertex is given by hk. So in order to identify the vertex here, well then our coordinates are 5 for h, 3 for k. So you can see you can determine what the vertex is directly from this form, and that's why it's so useful. You'll see why it's useful because we'll actually use this to help us make quick graphs of the quadratic function. All right, so let's look at an example. So before we do the example, let's show you the 3 different ways that the vertex form can actually transform a function. So again, let me write out what the vertex form is. We have f of x equals a times x minus h squared plus k. All right, so let's talk about what each of these things do. So the a has a few different functions. Okay, so if the a is positive, So this is our first little bullet point. So if A is positive, then this means that the graph opens upward. So the graph opens up. If the A is negative, the graph opens down. All right, so that's a couple of things that we need to know. And another thing is, if A is bigger than 1, then we have a vertical stretch. If A is less than 1, but greater than 0, then we have a vertical compression. Okay, so there's 4 things that the A can tell you. Now let's talk about the H. The H just tells you your horizontal translation. So it tells you your horizontal translation. So it basically tells you whether you're going left or right. Your K tells you your vertical translation. So basically whether you're going up or down. Okay, so now that we know those 3 things, let's do them in the example. So for part A, we have our A is -1/2. So that's my A. We're going to have to rewrite this in a different format. Okay, so we're going to have to rewrite this in this following format. So let me rewrite it. So we got g of x equals -1/2 times x minus -2 squared plus 0. All right, so the reason I rewrite this way is because now we got 2 positives or 2 negatives which make a positive, right? And we can identify what h is. So in this case, h is -2. So this is h. We know what A is. And now we know what K is. So remember that the vertex form was AX minus H squared plus K. So now we know these guys. So that's why I rewrite it in that form. So now we know that, basically know the vertex. So let's go ahead and write out the vertex. So the vertex is -2 for H and 0 for K. So that's our vertex. Now, looking at the A, this means this is telling us that A is actually negative. So since A is negative, the graph opens downward. And it also tells us that we have a vertical compression because 1/2 is less than 1. Okay, so let's quickly draw a graph so that you get an idea of how this looks like. So if we were to draw a graph, this is how, so in blue, this is how the graph of x squared looks like, the parent function. Let me redo this part. So this is how the graph x squared looks like. Now, if we want to graph this guy, well, we know that it's opening downward, right? So we know that it's opening down. So that means it's going down like this because of the negative. We also know that it's being compressed. So that means if it's compressed, that means it's shrinking. If it's shrinking, that means it's the numbers are getting smaller, are small. So these numbers are small. So this is right here is a shrink. Let me do this in a different color. If it's shrinking, that means it looks like this. So that's shrinking. Stretching, this would be stretching. If it was stretching, it would look like this. But since we're not stretching, we're shrinking or compressing. So that's compression. And it's shifted to, we forgot to say this part. So now this guy is actually shifting to the left 2. So this is shifting left 2 units. How do we know it's shifting to the left 2 units? It's because this is a negative 2. So that means that's telling us that it's shifting left 2 for the vertex. So that means that we need to move this guy over so that he's to the left. So that means take this guy, move it over left 2 units. So 1, 2. And then we get our final graph. Okay, so the graph given in purple is our final graph. Okay, so now let's look at the next one. So part B. We know that our A is 2. So this tells us that the graph is positive, so the graph opens up. Since A is greater than 1, which is 2, this tells us that the graph stretch, we have a vertical stretch. So vertical stretch by 2. All right, now for this part. And this part, this tells us our vertex. So our vertex is 1, sorry. Our vertex is 1 and negative 3. Okay, so now we got our vertex. So this means right here that since it's positive 1, it's shifting right 1. And this guy, since he's negative 3, is shifting down 3. So negative for the K means down, positive for the K means up, positive for the H means right, negative for the H means left. So now we got our transformations. So now we can graph it real quick. So if we do a quick graph, this right here is the regular x squared parent function. And then we got to transform it. So the A, we know it opens up, so it's going to be the same direction, but it's a vertical stretch of 2. So this means it's going to be bigger, it's going to go bigger faster. So it's going to look like this. So that's a vertical stretch. Next, we want to shift to the right 1 and then down 3. So we're going to shift right 1 and then down 3. Let me do this in a different color. So shift right 1 and then let's say we're going down 3. 1, 2, 3. In that case, this will be my new vertex. And then I'm going to draw my new parabola. Okay, so this is my final graph. All right, it doesn't have to be exact, it's just an approximation of the graph because I want you to just kind of visualize how it looks like. All right, go ahead and try the following problem. You're going to identify the transformations and then you're going to graph it. Just make a quick sketch. Okay, so let's go over the problems. So for the first one, again, let's write out the vertex form. So the vertex form is f of x equals a times x minus h squared plus k. All right, so we're going to rewrite this guy so that it looks like vertex form. So we got negative 1, there's an invisible 1 there, x minus negative 2 plus k. or plus 0, sorry, plus 0, and that's going to be our k. So this right here is our h, this right here is our k, and this right here is my a. All right, so now we know it opens down. Since a is equal to 1, it's not going to really do anything. There's no stretch or compress here. All right, so it's just going to open down because of the negative. All right, and then let's identify our vertex. So our vertex is -2, 0. So these guys. So since it's -2, that means it shifts left 2 units. And it doesn't go up or down at all because k is 0. So that's it. So now let's draw the quick graph. So this is going to be the normal graph. And then we're going to shift it to, and then it opens downward. So it goes like this. And then it shifts to the left 2. So we're going to shift it to the left 2. So 1, 2. And there's my graph. So that's my final graph. Okay, pretty straightforward. It's just a quick sketch. Now let's look at the next one. So here we're going to rewrite it. So actually, in this case, the a here is an invisible 1, right? So that's a, that's h, and that's k. So here we know our vertex is 1, 2 from our hk. Since a is 1, it doesn't do anything, but we know it opens upward since it's positive, since a is positive. So it opens up. And then since we have h is 1, it shifts to the right 2. So let me just right 1. So it shifts right 1. And then since k is 2, it's going to go up 2. All right, so let's do the graph real quick. So we got this graph. So this is the original parent parabola x squared. And then we're going to shift it to the right 1. And then we're going to go up 2. So 1, 2. And then it opens upward. So then we just draw the graph. Okay, so that's my final graph. Okay, pretty straightforward to actually sketch the graph. All right, so now let's look at another example. So now we want to actually determine the key features of the quadratic function. We already talked about how to find the vertex, so we're going to quickly review that. But we also want to go over axis of symmetry, minimum or maximum, and then as well as domain and range. So again, let me rewrite out the vertex form. So the vertex form is f of x equals a times x minus h squared plus k. So our vertex here, if we circle these guys, this is my h and this is my k. So we can easily identify the vertex. The vertex is going to be given by 3, 4. All right, so we know that this is my a. And that's going to tell us, you know, the stretch and all that stuff. Okay, so let's look at the axis of symmetry now. So axis of symmetry is pretty straightforward. So axis of symmetry. So the axis of symmetry is always going to be your h value. So it's x equals h. So that's the formula for the axis of symmetry. So so in this example, h is 3, right? So x is equal to 3. So that is the axis of symmetry. So now let's do the minimum or maximum. So we know that from the a value, the graph opens up since it's positive. So that means the graph looks like this, right? So since the graph opens up, right, that means that our vertex is here, and this is our minimum. So that means our minimum is that vertex. So we're going to give them, so the minimum is going to be the y value. All right, so the minimum here is equal to the y value. So k is like the y value. Okay, so remember this is h and this is k. So in this case, in this example, the minimum is equal to 4. Okay, so whatever the y coordinate is for the vertex, that's going to be our minimum or maximum. So if the graph opens up, that means we have a maximum. Or if the graph opens down, we have a maximum. If the graph opens up, we have a minimum. Okay, so now we're looking for the domain. The domain is very easy for this because the domain for any quadratic function is all real numbers. So the domain is negative infinity to infinity for all quadratics. Okay, so automatically negative infinity to infinity. And then for the range requires a little bit of work. Since we have a minimum, this means that our minimum number is down here and then it goes up from there, right? So it starts at 4 and a y value, so the y value here is 4 and then it goes up to infinity. So that means our range is from 4 to infinity. Here, let me change this. Okay. So we want to include the 4 since it's part of the graph. Infinity never gets a bracket. So that's our domain and range. All right, go ahead and try the following problem, and then we'll go over it in just a second. All right, so let's go over the problem. So let's rewrite the vertex form again, just to make sure that we remember. Okay, so in this case, let's rewrite this so that it looks like vertex form, because it kind of looks like vertex form, but we want to be able to identify HK. So we got a -1, an invisible 1 there, and then you got x. So you're going to rewrite the +4 into double negatives. So minus -4 squared plus, and I'm going to rewrite the minus as plus -5. The reason I do that is so that I can identify my HK. So now we know that this is my A, this is my H, and this is my K. All right, so if you see that we have plus K, we have minus H, which is -4, and then we have A. All right, so now we know what our vertex is. So our vertex is given by our H coordinate, -4, and our K coordinate, -5. Vertex is done. So now axis of symmetry, AOS, I'm going to abbreviate that, is going to be x equals to my H value. So x equals -4. So that's it for my axis of symmetry. Now this graph opens up or down. Well, you're going to be looking at this. Since that's negative, it opens down. That means my parabola will look something like this, which means that we have a maximum. Where's the maximum? The maximum is the y coordinate. So then we have a maximum equal to the y coordinate, which is -5. So that is our maximum. Okay, so now we're going to do our domain. Domain is easy. Since it's a quadratic function, it's automatically going to be all real numbers, -infinity to +infinity. For the range, so you want to look at the graph to guide you. So that means, so if we go from bottom to top, right? Since these are arrows that go forever, that means that from the bottom we have -infinity all the way to the very, 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 very top. We have the maximum value, which is at y equals -5. So that means the range is from -infinity to 5. And we don't want to include negative infinity, so parentheses for negative infinity, but we do want to include negative 5 since that's part of the graph. All right, so now let's move on to the next example. So we want to be able to determine the equation of a parabola this time if I give you 2 coordinates. So in this case, we want to determine the equation if I'm given the vertex and the y-intercept. All right, so since they give us our vertex, we now know that this is h, and we now know that this is k. So we want to be able to write this in vertex form. So remember, vertex form is f of x equals a times x minus h squared plus k. So we got f of x equals a. We don't know what a is yet. We do know that h is negative 2. So we got here negative 2 squared plus, and then we know that k is 3. Okay, so let's rewrite this real quick. So f of x equals a times x. Now we got this 2 negatives make a positive. So we got plus 2 squared and then plus 3. So that is our vertex form so far. We're almost done. We just got to find a. So we need to find out what a is. So we're going to be using this information to help us find it. So if our y-intercept is negative 1, this means that we have our coordinates are 0, negative 1. So for example, if my y-intercept was 2, then our coordinates would be 0, 2. Okay, so now we know our x and we know our y. Y is the same thing as f of x. So if you see f of x, just think of it as y. So we know our y is negative 1 and we know our x is 0. So we're going to plug those in. So we know that this is going to be plugged in for f of x. So we got negative 1 equals a times x is not going to be replaced with 0. So we got 0 plus 2 squared plus 3. Alright, so we're going to combine these guys. 0 plus 2 is simply 2. So we got a times 2 squared plus 3. So 2 squared is 4. So we got ourselves 4a plus 3. Now we got to subtract 3 on both sides. Solve this equation for a. We got negative 4 equals 4a. Divide both sides by 4. We got a equals negative 1. Alright, so now that we know a is negative 1, we're going to plug it into a here. So if we do that, we get f of x equals negative 1 x plus 2 squared plus 3. And that's my vertex form. Alright, go ahead and try the following problem. So pause the video real quick, and then I'll go over it. Alright, so let's do the example. Same as it was last time. So we got ourselves a vertex. So we know that this right here is my h. The negative 4 is my k. Okay, so now we got f of x equals, remember that the formula was a x minus h squared plus k. So in this case we have f of x equals a x minus, so now h is 1. Change that real quick. Squared plus, and in this case k is negative 4. Okay, so now we can rewrite this as a negative, so we can just write it as minus 4. Okay, so I'm going to rewrite that as a negative. So we got f of x equals a times x minus 1 squared minus 4. So now we got to find a. So we're going to be using this information to find a. Okay, so if we look at the coordinates, this is my x and this is my y, or otherwise known as f of x. So let's plug that in for f of x. We have -1 equals a times x is now going to be replaced with -2 minus 1 squared minus 4. So this right here is going to be -3. So we got -1 equals a times -3 squared minus 4. -3 squared is 9. So we got -1 equals 9a minus 4. So add 4 to both sides. So we got 3 equals 9a, divide by 9 on both sides. And we get a equals 3 over 9. So you can actually reduce that by dividing by 3 in top and bottom. And you're going to get a is equal to 1/3. So now you're going to take that and plug it in for a here and get your final answer. So f of x equals 1/3 x minus 1 squared minus 4. That's our vertex form. All right, so let's look at another example. So pretty similar, except now we got in terms of a word example, like a word problem. So the height of a thrown ball is a quadratic function of the time it has been in the air. The graph of the quadratic function is the parabolic path of the ball. The vertex of the graph is 120, and the path of the ball includes the point 0,4. What is an expression that defines this function? Write the quadratic equation in vertex form and in the form y equals ax squared plus bx plus c. Alright, so we have a similar problem to example 3, except now they want us to also put it in this form. So that form is actually going to take a while to do. But let's focus on the first part. So we want an expression that defines this function in vertex form. So again, we know that this is h, and we know that this is k. So let's start with there. So we got here f of x equals a times x minus, now h is 1, squared plus k being 20. So now we're going to use the point 0,4 in order to plug it in. So remember the point 0,4, x is 0, and y or f of x is 4. So let's plug those in. So we got 4 equals, let me change that, equals a times x is now going to be 0, so 0 minus 1 squared plus 20. Alright, so this is going to be -1, so 4 equals a times -1 squared plus 20. -1 times -1 is 1, so we get 1a. So 4 equals 1a plus 20. I decided not to write the 1. Like there's a 1 there, but I'm erasing it, so it's invisible. So now subtract 20 on both sides. So we have -16 equals a. Alright, so now we got a. We can plug in a into here and get our vertex form. So we got f of x equals -16 x minus 1 squared plus 20. Alright, so that's our vertex form. Alright, so next what we want to do is we want to write it in this form. So how do we do that? Well, to do that, we need to actually FOIL the x minus 1 squared out. So we need to FOIL, FOIL this part. That's the part that's going to take a lot of work. So let's go ahead and get started. So let me write it over here. So we got f of x equals -16 times parentheses. Now, we're going to rewrite this as x minus 1 times x minus 1 because we have a squared right there. So that means we have two of them. So x minus 1 times x minus 1. And then we got plus 20. Okay, so this right here is a FOIL. So this is first, outer, inner, last. So we got to FOIL that guy. So if we did that, so we got negative 16 times, I'm going to keep this in blue. So we got x times x is x squared. X times negative 1 is negative x. Negative 1 times x is negative x. And then negative 1 times negative 1 is positive 1. And then, of course, bring down the plus 20. All right, so now we're going to combine these like terms, and that'll give us negative 2x. So we got x squared, and that part right there, so let me do this in green. So this right here is going to be negative 2x. So minus 2x, and then plus 1 plus 20. Okay, so now for this, we're going to have to distribute the negative 16 to each and every one of these terms. So negative 16 times x squared is negative 16x squared. Negative 16 times negative 2x is positive 32. Negative 16 times positive 1 is negative 16. And then we got plus 20. All right, so now you're going to combine these like terms here. So we got negative 16x squared plus 32x. And then we got 20 minus 16 is positive 4. All right, there is our final form. Okay, so notice that we got ax squared plus bx plus c. So this is a, that's b, and that's c. Okay, so if we're trying to convert to this form, oops. So if we're trying to convert to this form, then we achieve that form. Okay, so this takes a lot of work because you got to FOIL and simplify it. But it's the same process throughout, so no matter what type of problem you're dealing with. All right, go ahead and pause the video and try the following problem first. Okay, so let's look at the following problem. So it looks like we have, the same type of problem where we're given, the vertex and all of that. So here we know that this right here is the vertex. So this right here is H. This right here is K. And we're given another coordinate that we're going to use later. So again, so f of x equals a times x minus h squared plus k. So we got f of x equals a, we don't know what a is. H is going to be 2 squared plus k. All right, so now we're going to find a. So we're going to be using these coordinates here. So now this is going to be my x. That's going to be my y. My f of x, or y, same thing. So if we plug it in, we get 4 equals a times 0 minus 2 squared plus 10. So this is going to be negative 2. So 4 equals a times negative 2 squared plus 10. Negative 2 squared is 4. So 4 equals 4a plus 10 minus 10 on both sides. So we got negative 6 equals 4a, divide by 4 on both sides. So we get a equals negative 6 over 4. But we can reduce that by dividing by 2, top and bottom. So a equals negative 3 over 2. All right, so now we know what a is. So we're going to plug it in here. Oops, not that one. So plug it in here. Let's try it again. So we're going to plug this in for a here. All right. And then that'll give us our answer for the vertex form. So for the vertex form, just write it over here. We have f of x equals negative 3 over 2 x minus 2 squared plus 10. All right, so that's our vertex form. So now we have to simplify this, right? So we have to put it in ax squared plus bx plus c form. So we're going to have to FOIL this guy. So we're going to rewrite it. Since we have two of them, we're going to write it as x minus 2 times x minus 2. Okay, so far we got f of x equals negative 3 over 2. We got two of these guys. So x minus 2 times x minus 2. And then plus 10. Okay, so this is going to be a FOIL. So we got negative 3 halves times, so x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. And negative 2 times negative 2 is positive 4. So we got negative 3 over 2. Now we're going to combine these like terms. So negative 2x and negative 2x make negative 4x. So we got x squared minus 4x plus 4 plus 10. So now we got to distribute these guys. So we got negative 3 halves x squared is negative 3 halves times x squared, just like that. So now we got to do negative 3 halves times negative 4. So let's do that on the side. So negative 3 halves times negative 4. So negative 4 is the same thing as negative 4 over 1. And then you multiply straight across. So this is going to give me negative 3 times negative 4 is 12. And then 2 times 1 is 2. So 12 divided by 2 is 6. So that means that this is going to give me positive 6, and then don't forget the x here. So positive 6x. Okay? And then in the same way, negative 3 halves times positive 4 is going to be negative 6. We just found it here. We got 6 there. And then plus 10. So you want to combine those like terms, and then you get our final answer. Negative 3 halves x squared plus 6x plus 4. All right, and there's our other form. So we got both of these forms. All right, and that's it, guys. I hope you found this video useful, and it just takes a lot of practice to be able to convert between the forms and find the vertex form. But otherwise, once you are able to memorize the vertex form and determine the vertex, it gets easier. All right, so guys, go ahead and have a good day, and I'll see you in the next video.